Okay, hopefully you're able to write down some numbers. What is the, I'm going to not just write down A here, I'm going to write down probability of A. Probability of A is what, and probability of B is what? What are each of those? 50-50, 1 out of 2. Let's write them as fractions here, 1 out of 2. What is the probability of each of the other things here? What is the probability of getting a 0 given that you are, I don't want to complicate things here, but probability of getting $0 given that A is the one that you selected? It's 1 out of 3. Is that the same as the probability of getting 0 given that B was the one that was selected? What is the probability of getting a 0 given that B was selected? 1 out of 4, right? Those are different. Okay? Getting a 0 and is dependent on which pot you pick. We can put the other numbers in here without all the probabilities. What's the chance of getting a 10 in the first pot here? 1 and 3, 1 and 3. Each of those is 1 and 3. This is 1 and 4, but what's his chance of a 10 in the second one? 1/2 or 2/4. Maybe let's leave it as 2/4 just so it matches the other ones there, and you can see they all add up. Up above here, a $10, what is the probability that a $10 bill is selected if it is known that, so this is where this condition comes in. We wrote those out down there. Probability of a 10 if it is known that pot A is selected, given that A was selected. What's the chance of that? What did we say? 1 out of 3? What is the chance of a 10 given that B was the one that was selected? 1 out of 4. What is the chance that a $10 bill is chosen altogether? Regardless, if you don't know, you have to do some thinking here. It could happen 2 different ways, right? There are 2 different cases. 2 cases, right? Here are your 2 different cases. Here's one of the cases. A and a 10. Here's the other case. B and a 10 down there, right? Those are the 2 different ways it can happen. I would like us to write out each of the cases down at the bottom here. So there's a bunch of things that can happen here. This can happen, right? This can happen. Well, let's write out those 2. What's the chance that each of these is going to happen? I am not leaving myself with a lot of room, so I'm going to write probability of a 10 is probability of A and a 10 plus probability of B and a 10. It can happen 2 different ways, so you add those 2 probabilities together. How do we work out each of those? What's the chance of getting A and a 10? Here's A. Here's a 10 given that A happened. What do I do with those numbers? Multiply them, right? 1/2 times 1/3. Or in other words, 1/6. What's this other one here? B and a 10 is, B is 1/2, 10 is 2/4. What does that give me? 1/4, 2/8, 1/4, 1/2, well, times 1/2, 2/4. This is 1/4. All right, can we work out what that is? I don't have a lot of room here, so I'm going to put this over here. What does that work out to? What do I need to do? You probably should write them with common denominators. I am actually going to move this down here so I don't make a mess of it. It is 5/12. You got to remember some things about fractions, or you can use your calculator. It doesn't matter, whatever you're more comfortable with. If you make a common denominator there to add them, you have 2/12 plus 3/12. This gives you how many 12s? 5/12. That's what the chance is. That's a probability of getting a 10. All right. You have to realize that there's 2 different cases there and add them together. Now the hard part is this, asking this conditional question at the end here. This is the key, okay? That's the key to this conditional thing here. You need to translate this into something. if it is a $10 bill that is chosen, if a $10 bill is chosen, what is the probability that it came from pot A? Start by translating that using the symbols into a conditional probability. Probability of something given something. Think about what that means. Write that out, and then we'll approach how we're going to solve this. Okay, I'm going to pause this for a second while you try and think about that. Write down what it is. Probability of what given... What is this? This is probability of what? Probability of... It says if it's a $10 bill chosen, they tell you a $10 bill is chosen. So that's not the thing that comes first here. That's not what we want to know the probability of. It says what's the probability of A. It's what's the probability of A, but the condition is if it's a 10 that's chosen. So this is what is the probability that came from A given that you ended up with a 10. Doesn't that seem a bit backwards from the way it works? Why might a person call this a backwards question or situation? What happens first in this situation? What's that? Well, look back at this. Which thing happens first? Yeah, first you pick one of the two pots, and then you see what bill you had. So it seems kind of goofy to ask you, what's the chance that it came from A after we got to the end here and have a 10? Once you're standing there with a 10 in your hand? There's a lot of things that are like that where they're backwards like that, where you don't know the one that came first, but you do know the one that came second. One of the prime examples is medical tests. Medical tests, there you can do some questions like that. First of all, here's a person, and they either have a disease or they don't have a disease. Certain disease, I don't know, whatever. Some kind of disease. Then they say, I don't know if I have this disease, I need to take a test. So the test is either positive or negative. The test turns out positive or negative in either case. Which one? No, we're not going to name the disease. It's just an unnamed disease. Which one of those things do you actually find out first?
Do you have the disease or not?
No, which one do you find out first? Like, you have the disease or not first, but you don't know whether you have the disease or not?
You ask the question.
You take the test, and then you say, does that actually mean I have the disease or not, right? What I'm saying here is...
So the D is taking the disease test.
No, the D is either having it or not having it.
Okay, so that... Yeah, but well, you would know if you have it.
You might not know, right? That's why you're taking the test. You don't know if you have it.
But then when you only take one?
Yeah.
No, because a person that has a disease, even though they don't know it, can test positive or negative. Or a person that does not have it can test positive or negative.
Oh, I see it.
Oh,
so you need to have a little line going up to that, I think.
To what?
From
Well,
to the actual test.
I'm showing you this because this is. I want you to see what this is backwards from what I asked you before. Look up here. This said, what's the chance of getting a 10 given that it's A, right? That says, what's the chance that the bill you end up with is 10 given that you got A? That seemed to make sense from what it is, because you first pick one of the pots to choose, and then you pick one of the bills out of that. So first it's A or B, then it's 10 or not a 10, right? But this question here is the reverse of that, right? You got to see that this is the reverse of that. Just make sure you understand this first. This is the reverse of that, is it not? This is saying if it turns out in the end that you're standing there holding a $10 bill, what's the chance it came from A? This seems stupid because if this was a game, you'd know whether it came from A or not. But there are situations where the thing that happens second is the first one you find out. You get a test result, and then the doctor uses the test result to actually figure out if you have the disease or not. Not all, you know those tests say this test is 95% accurate or whatever? You take the test after you actually have the disease or not, right?
But why would you take the test if you know not?
You don't know at this point.
You slip on a dirty road.
Here's this person. We found some random person outside.
Oh.
They might have this disease or not. We don't know, right? But they actually already have it or not. That's happened. That's occurred already.
Yeah, it's passed.
It's passed. It's the thing that happens first. They either have it or they don't. We run the test. We find out if the test is positive or negative, but we still don't really know whether they have it or not. It's based on how good our test is. Right? The thing that happens second is the first one we find out. In this case, you might want to know, what's the probability of actually having the disease given that you tested positive? This is where you might want to know, what is the chance the first thing has happened given that this happened? Okay? We'll get there.